Orientation, there we go. Okay, so as I mentioned, we're actually going to start with the easier of the problems and then we'll build the harder ones. So the easier one is actually here on this side of the page and then we'll move over to the other side. So 14, when a plane passes through a cone, and they show you a picture here which is nice, to create a cross-section that is parallel to the base, the resulting two-dimensional shape of the cross-section is a what? So it's saying like a plane cuts this thing right here. What's the resulting shape right here? It is a circle. And that's all they're looking for. (14b), when a plane passes through a cone to create a cross-section that is perpendicular to the base, the resulting two-dimensional shape is a what? So if it was sliced right here, what would be the shape? It is a triangle. And then the next one, when a plane passes through a cone to create a cross-section that is diagonal to the base, the resulting two-dimensional shape of the cross-section is a what? What does it look like? It looks like an oval, right? They don't call it an oval, though. They call it an ellipse. And there are some of those on the EOC. Those are the easier ones that you can get correct. Number 15. It says, Kendra has a compost box that has the shape of a cube. So drawing a cube, when you draw a cube, just start out with a square for the front. And then draw a square behind. And then connect the corners. And there you have a cube. She wants to increase the size of the box by extending every edge of the box by half of its original length. After the box is increased in size, which of the following statements is true? They don't give us any numbers, but they're looking for how much larger the volume is as a percent. So the best way to do this is just choose your own numbers. So let's say that the side length of the cube is 2 by 2 by 2. So the volume of the original, which would be side length times side length times side length, 2 times 2 times 2. So the volume equals 8 units cubed. Great. Then it says that we have another cube, and each side length is extended by half of this. So what that means, here I'm drawing a cube a little bit bigger.
It will be 3 by 3 by 3.
Good call. So if each one of these, like half of 2 is 1, so just add that to the 2 to get 3 by 3 by 3. So the volume would be 3 times 3 times 3. 9 times 3 is 27. The volume of this one is 27 units cubed. Again, these are just like sample numbers. Then it says, okay, how much did it increase, like in percent? You can take 27 and divide it by 8, and you would get 3.375. That's as a decimal. To turn a decimal into a percent, you can multiply by 100, or move the decimal over 2 places to get 337.5%.
I was thinking 150%.
That would be the side lengths are increasing by that, but the volume increases by, yeah.
That one was tricky.
Yeah, but not too tricky now that you know what to do. Okay, the other side of this worksheet has a concept that we haven't learned before. So down here, I'm going to quickly go over the concept. It's called Cavalier's principle. Cavalier's principle. This actually comes up this week, so it's nice to just kind of preview it. That way it'll be easier to learn when you see it. There's Cavalier's principle of area and Cavalier's principle of volume. We're going to start with area. So for example, if you have a triangle here, and the base of this triangle is 5, and the height is 4. To find the area, it would be 1/2 base times height, right? Then what if you had a triangle that was kind of skewed off to the side, like this, but the base was still 5 and the height was still 4? Since the bases and the heights are the same, then the area of those two triangles are the same. Area is the same for those two. Okay, and the same applies for volume. And a lot of times you'll see shapes that look like this. So here's a cylinder. And then what happens if the cylinder is like this? Wait. Trying to make it proportional. Okay, so here's two cylinders. So if their bases are the same measure, so if the base equals the base and the height equals the height, there's another factor here, and it's cross section. So if you're to slice these two at the same height, their cross section should be the same area. So if you're to slice it at the same height, their cross section should be the same area. So if the cross section equals the cross section, then their volumes will equal as well. That's the concept. So a shape like this would actually have the same volume as this, as long as the bases and the heights are the same area. And the cross sections are the same. And there's also some practice with this on Khan Academy this week as well. Okay, so there's a concept. Let's look at actual questions. This first one starts by explaining the concept. If two pyramids have congruent bases and the same height, their cross-sections at any height must be congruent. By Cavalieri's principle, it follows that the volumes of the pyramids are the same. Kind of same thing I explained. It says, consider this triangular prism, and we're going to answer the questions based on this. And this jumps a little bit, so just follow. It says, what is the relationship between the area of triangle ABD and EDB? So looking at those triangles, ABD would be right here. There's a triangle. And then the area of EDB, so this triangle here. What is the relationship there between the areas? Well, they have the same base and the same height. So therefore, those triangles are the same area. Same base, same height. Therefore, they have the same area. Okay, they're going to bring in another concept here. Okay, so this jumps a little bit. They're saying that inside this prism there are pyramids, and they create like a pyramid. So consider the pyramid A, B, D, C. So here is a pyramid. We're going to, this is the top of the pyramid, and then this is the base of the pyramid here. I don't know how well you can see that. Can you kind of see that? And then here's the back of the pyramid. So it's a triangular pyramid. Then there is also a pyramid that goes the other way. So this would be the top of the pyramid. Here it is here. Here's the back side of the pyramid. And here is the front to there. So there's a pyramid that goes this way. Consider these pyramids. What is the relationship between their bases and heights? Well, they actually share the same exact base, and their heights are the same. So same base, same height. And then what is the relationship between their volumes? Well, if they have the same base and the same height, then their volumes would be the same. Volumes are the same. And again, we are covering that this week. There's also some practice on Khan Academy with the whole concept of that as well. Okay, 12. What is the volume of the triangular pyramid? Well, the equation for volume of a pyramid is 1/3 area of the base times the height. Capital B is area of the base. In a triangular pyramid, the bottom is a triangle, so we have to find the area of that triangle first. The area of a triangle is 1/2 base times height. So we will plug these numbers into the equation. So 1/2, 6 times the height of the triangle is 8. When we solve this, we can multiply these numbers in any order. You could do 6 times 8 first to get 48, and then divide that by 2. Or you could do half of 6 is 3, and then multiply that by 8. Area equals 24 centimeters squared. That's the area of that base.
I can't believe I got threw off by that triangle.
Then we take the area of the base and we plug it into the volume equation. Volume equals 1/3, area of the base is 24, and the height is 5. Again, you can multiply these in any order. 1/3 of 24 is 8. And volume equals 40 centimeters cubed.
I can't believe I got thrown off.
Okay, 13. What is the scale factor of these two pyramids with volumes of 8 feet cubed? So volume equals 8 feet cubed. And the volume of this one is 343 feet cubed. What is the scale factor? Well, the scale factor would have to be like this dimension compared to this one. It's 1D, not 3-dimensional. So in order to find the scale factor, we need to find like this length. We're not going to do all that work though. We're just going to take the cubed root of each of these. So the cubed root of 8 and the cubed root of 343. In the calculator, or this calculator, it's kind of tricky to do. There's this button, the green button back there. It shows like square root, but you can choose the number that goes on the outside. So we can do 8, second that button, 8, nope, just kidding, 8, second the button, 3 equals 2. Sometimes it takes some trial and error. Okay, let me do that again. So I did 8, second the button, then 3 to get 2. So the cubed root of 8 is 2, which you may have already known. And then for 343, same process, 343, second this button, 3 equals 7. So the answer is 2 to 7. And that's it. Okay, so for the rest of class, you're going to use it to start your Khan Academy for the week, and then you can take turns going to the Media Center to print notes if you need to print your notes for tomorrow.